Hi everyone, welcome back. My name is Anand, and today we're going to be talking about stacks. So the stack data structure is one that follows the LIFO principle, which stands for last in, first out. And to visualize this, it's intuitively exactly what you expected. If you had a stack of books, the last book you insert or add to your stack is the first one that you're going to remove. And as a result, all the operations we define for a stack are going to be done at the top of the stack only. The reason for using the stack is mainly for situations where the LIFO principle is applicable, and when it is, it's pretty easy to implement the stack. And a good real-world example of this is with undo, redo buttons, as well as back and forward pages on your browser, where each time you're going back, you're popping off the stack, and otherwise you're pushing to the stack and moving forward. And one of the cons, which also applies to data structures in general, is that it's uniquely suited only to LIFO situations. Outside of that, it's not very applicable. So the operations for a stack include push, pop, and peek, where push is the insertion and adds to the top of the stack, pop removes from the top of the stack and returns the value of the element, and peek allows us to see what's at the top of the stack without interacting with it. And this is a good example right here. And next, now that we've defined the stack and its operations, we're going to be writing a method that takes in a string and reverses it using a stack. And now that I've made it to my code editor, I'll be writing the method to reverse a string using a stack. And to start off, the first thing I'll do is obviously import java.util, which defines the stack class for us. And within the stack, I'm going to give it the type of character so that we can add characters from the string to it. And the intuition behind how we're going to do this is assume we have a string inputted ABC. If we push everything to the stack sequentially going through, we can add A, B, and C. And as we pop off, the order comes in reverse, where we pop off only from the top, which is the last element added, which will be the last character. So we'll pop off in the order C, B, A, which will be the reverse of our input string. So just to implement this, next I'll iterate through the characters of the string using the method toCharArray. And here I'll push to the stack. And now that my stack is full with the elements from the input string, I'll iterate through the stack one more time and pop off into a string builder. So string builder. And now I'll iterate through the stack using a while loop. And this is another functionality of many data structures, and the stack in particular, where we can say stack.isEmpty. So basically, while the stack is not empty, meaning it has elements, we'll iterate through and pop off into our resulting string builder. So I'll append stack.pop. And this is a good time to remember that the pop operation returns the value of the element that's at the top and removes it from our stack. And this is it. Now I can just return the result as a string, and we should be good to go. And here we have it. For reverse ABC, I get CBA as my output. Finally, to recap, today we went over the stack data structure, which follows the last in, first out principle, and it has a variety of real-world applications, one being the call stack in Java. If you remember, when we recursively call methods, they are pushed onto the stack as they are called, and as they return a value or finish execution, they're sequentially popped off. And we also define the relevant operations for stack, which include push, pop, and peek. And that's all for today, and I'll see you guys in the next one.